Hello. So what we're going to do today is we're going to talk about how to classify these things called polynomials that we were working on in the last lesson. All right, so we know how to add and subtract them, right? It's just like fancy combining like terms. But sometimes it's helpful to know how to name these things that you're talking about. Right, so the way that we do that is we name them by the degree of the polynomial and also by how many terms it has. Right, so to find the degree, what we want to do is we want to look at the term with the highest exponent or sum of exponents, right? So you might have more than one term in a polynomial. In fact, that's what you're going to have a lot of the time. You're going to want to look for the one with the highest degree, right? And that one's going to kind of win out for the naming of it, right? So for something like a to the third up there, right? If the degree is 3, right? Because that's what a to the third is, right? We just grab that. It's just the exponent of the variable. For something where you've got more than one variable, like x to the fourth y squared, you just add the 4 and the 2, and that gives you a degree of 6. Right? For something like that third one there, 5 to the third, s to the fifth, and t squared, you only count the variable exponents, right? So that degree is 7. Right? We have all these different names for them. If it's just a constant, right, no variables at all, it's got a degree of 0, right? So it's just a constant. If it has a degree of 1, we call it linear, right? These are the ones that would result in a graph, where you'd have, a line, just like you've graphed in the past, right? That's what those would come out as if you graphed them. If you have a degree of 2, it's called a quadratic, right? Those ones have graphs that look like, parabolas, which you've probably heard about in the past. If it has a degree of 3, it is called cubic, right? Not that it's super important, but those graphs you'll run into eventually sort of look something like that. Like it's kind of like a little curviness going up and down, right? If it has a degree of 4, you call it quartic. Degree 5 is called quintic, right? And then after you get to 5, right, you could keep on going, but most of the time people don't really remember the names of those ones. What you just say is it's of degree whatever it is, right? So if I have something that's of degree 20, I'm not going to figure out that it's like a dodecic or something like that. I'm just going to say, oh yeah, this is a polynomial of degree 80, 85, whatever. Right? The other way that we name it is we base it off the number of terms over here on the right. So, terms are the big like chunky pieces of the expression, right? So if you only have one term, it's called a monomial, right? It could be just a number, like you might just have 16. You might have just a variable, like x to the fourth, or you might have some of each, right? If you had 3y squared, just that would be its own term. It would be a monomial. You could have y squared z, just that, right? No 3. That would also be a monomial. Or you can have everything all kind of mixed together, right? As long as it's one chunk of stuff, then that is a monomial. It's got one term, right? Underneath that, right, if it's got 2 terms, it's a binomial, right? Bi meaning 2, right? So 2 terms, 2 chunks, that's all there really is to it, right? The important part is that they are connected by either an addition or subtraction sign, right? That's how you can tell that whether they are one big term or not, right? I will say that on this one, if this was multiplied, right, then I would just consider this as one big term, right? Because if they're multiplied, then it's all just kind of, you can smush it all together, right? But if it's added or subtracted like it is there, that's how we can tell that they are split up into 2 different terms. If you have 3 terms, it's called a trinomial, right? Tri meaning 3, just like we got down there. And then 4 or more terms, you just call it a polynomial, right? There's not really, like you could come up with some special names for them, but a lot of people would just call that a polynomial, right? So for example, if we wanted to kind of put these 2 ideas together, let's say that I was trying to name that thing that I just highlighted there, right? I would name it based on the degree. So what I'm looking at is I'm looking at those 3 different terms and trying to figure out which one has the highest degree, right? This first one has a degree of 2, right? It says a squared. The second one has a degree of 2 as well, right? B and C each count for 1. And then this third term has a degree of 6, right? Because it's d to the 6th power, right? So this one would win out in terms of, getting to choose what the degree is overall, right? So we would call this a trinomial, because it's got 3 terms, of degree 6, right? That one on the bottom here, right, this 4 or more terms one, again, I'm taking a look at the degrees. This first term has a degree of 0, right? There's no variables. Second one has a degree of 3, right? 2 from the x and 1 from the y. Whoops, I don't know why it's doing that. Right, so we got 0, we got 3. That third one there, 19z to the 7th, right? That 7 is telling me that that degree is 7. And then that j just has a degree of 1. Right, so the 7 wins out. What I would do is I would call this a polynomial of degree 7, right? So let's take a look at a couple examples together, right? I'm not going to go through every single one that's on the back. I'm going to leave some up to you, but we'll talk through a couple just to kind of see where we're at. So let's start with number 1. If I'm looking at number 1, we've got 6x to the 4th, right? So think first about how many terms does it have and what's the degree, right? So how about, let's start with the degree. If I'm trying to figure out the degree of this thing, I'm looking at the exponents of the variables, right? This has just got one variable, and it's got a 4th power on it. So the degree is 4, right? If you flip back to the other side, you'll see that if we have a degree of 4, we call it quartic, right? If it helps to kind of remember them, right? Quart kind of reminds you of like the word quarter. It's 1/4 of something, right? So quartic is what we would do for the degree. And then as far as the terms, right, how many terms is that? It's just one chunk of stuff. Actually, let me color code this even a little better. I'm thinking about how many terms it has. It's just one, right? If it has just one, we call it a monomial, right? Mono meaning one, right? So the overall name for this is exactly what I've got there, right? We would call this a quartic monomial, right? And that's all we're trying to get to. Quartic monomial, cool, done. Right, let's take a look at this number 2 right next to it, right? I'll leave number 1 up there, right? So first things first, I'm going to look at the degree, right? So on this one, we've got multiple different things, right? So just like those examples we did on the front side of this, what I need to do is I need to take a look at the degree of each term and then choose the biggest one, right? So the degree of that first term is just 1, right? That's what's on that x. It's just kind of hiding out invisibly, right? So that has a degree of 1 over there. And then this other one has a degree of 3, right? So the 3 is going to win out. My degree overall for everything is 3. And again, if you'll take a look on the front, if it has a degree of 3, we call that cubic. Right? In terms of the number of terms, right, we're just going to take a look at how many chunks we've got that are separated by addition and subtraction. I've got 2 chunks, so that's 2 terms. If I've got 2 terms, right, we call it a binomial, right, because bi means 2. So again, all I really need to do when I'm naming it out is call it a cubic binomial. And that's it, right? If it helps to write things out as like explicitly as I just did there, right? Degree, terms, right? If it helps to do that, go for it, right? If you're able to just see, you know, like, oh, it's got 1 term, monomial. You do not need to write that part, right? That's okay. If you can do some of it in your head, that's great. If you're feeling a little like, yeah, I don't know, while you're getting used to them, you know, keep doing it the way that we're doing it here, right? Let's take a look at 5 and 6, and then I think I'm actually going to leave the rest to you. Right? So for 5, right below it, first things first, I'm going to take a look at the degree. Right, so take a second, see if you can figure out which one of those terms has the highest degree, and think about what it is. So if we gave it a go, right? If I'm taking a look at the degrees of these, right? The degree of this first one is 6. That's the only exponent on a variable. Degree of that second term is 8. And the degree of this third one is actually 3 overall, right? It's got a 2 and then a 1 on that v, right? So I want to choose the largest of those. So my degree in this case is 8. So if you flip back to the front of this, right, you'll notice that we don't have a special name for when it's got a degree of 8. So we're just going to say of degree 8, right? If the number's not too weird to say out, you can also just say like it's an 8th degree ... right? People say like I'm a 2nd level black belt, something like that. You could say it kind of like that, 8th degree blah blah blah. Right? As far as the blah 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 goes, that's going to be what our term is for the number of terms. So thinking about how many terms this has, 1, 2, 3 that are all separated by addition and subtraction. Right? So if it's got 3 terms, right? Again, if you need to flip back and over to take a look at these, that's okay. If it's got 3 terms, we call it a trinomial. Right? Tri meaning 3. So when I'm writing this out, right, I would call this, either a trinomial of degree 8, or alternatively, either one of these is fine. I could call it an 8th degree trinomial. Oops. Right. Either one of those would be A-okay. Right. Last little one that we're going to take a look through is number 6. So all you do is pause here, give it a shot, and see what you get, right? And then unpause and see what I did, right? See if you really know what you're doing. So hopefully you gave it a go, right? Let's start off with the degree. Right, so again, I need to take a look at each individual term, figure out the degree of that thing, right? I want to choose then the highest of those numbers. So the degree on this first term, right, each one of those variables has a little 1 on it. So that overall degree is 3 there. D, E, and F in the middle also each have a little 1 on them, so that degree is also 3. This last one over here has got 4 different variables, right? Each one of them with its own little first power on it, right? Just like all these other ones. So that one has a degree of 4. So that's what I'm going to choose overall, a degree of 4. Right? So again, we call it a quartic when we've got degree 4. Right? After that, I'm taking a look at the number of terms in here. All right, so I'm taking a look at the number of terms. I've got 3 different chunks that are separated by adding and subtracting. So my terms are 3. That means that I call it a trinomial. Right? So again, end of the day, all we got to do is smush those together. It's a quartic trinomial. Right? So what I'd like you to do from here on out is try the other ones on your own, right? Some of them look a little scary, right? But we're going to do it the same way we just finished those ones, right? You have that whole big graphic organizer on the front of this. Take a look at that if you get a little bit stuck. If you're still stuck at the end of all that, right, be sure to ask about it next time I see you, all right? And with that, I'm going to finish it off there. Nice, easy, quick one. See you next time. Bye.